Okay, so the first lesson for term 3. Now we're starting with calculus, and our first topic within calculus would be the remainder theorem. Okay, so the remainder theorem states that if a polynomial fx is divided by a linear polynomial ax plus b, then the remainder r, which is the remainder, equals f bracket negative b over a bracket. Okay, so please pause and make a note of this, write it down. Okay. So the quick way to explain that is if I have something like this and they ask me to divide it by a linear polynomial, how do I do that? And that sounds really difficult, but it is really easy. Okay, so let's look at it. Example 1. Use the remainder theorem to determine the remainder when fx equals fx to the power of 3 negative 8x squared plus x plus 2 is divided by. Okay, then they give me 3 things to divide it by. So as soon as they say remainder theorem, your formula of the remainder needs to pop in your head. Okay, so please pause and make a note of this. Okay, so fx divided by x plus 4. So then I take this will be my a, whatever's in front of x would be my a, and my constant would be my b. Okay, then I put it back into my formula. Remainder equals f bracket negative b. I substitute whatever b is, which is 4 in this instance, and a, which is whatever's in front of x, and there's nothing in front of x, which means there's a secretive 1. Okay, if there's nothing, there's 1. Okay, which means my remainder for this one would be f negative 4. Then I replace that back into my fx. So whatever the long one was that they gave me, I replace it back in. So then I'm going to substitute x with negative 4. Okay, so wherever I see x, then I'm going to make it negative 4. So 4 bracket negative 4 to the power of 3 minus 8 bracket negative 4 to the power of 2 plus negative 4 plus 2 would give me a negative 386. Okay, so that would be my answer. What would happen if I divided fx with x plus 4? I would get a value of negative 386. Okay, now please pause this video and try to do b. Okay, so what would happen if fx is divided by 2x plus 1? Okay, so please stop it and try. Okay, so how to solve b? If fx is divided by 2x plus 1. Now, again, I'm going to use my remainder theorem for that, saying that r, which is my remainder, equals f, and then substitute that in negative b over a. My b in this instance is 1. My a is 2. Now I'm going to replace wherever I see x with negative 1 over 2. And if I substitute that in, I'm going to get like f, negative 1 over 2, is equal to negative 1, which means my remainder, my r, would be negative 1. Okay, so please pause and try C. Okay, so fx divided by 2x negative 5. So then my remainder, so each time we're talking about a remainder and we're asking, like, if we divide the long fx, which is this one, divided by that, or that divided by this, what would remain? So our remainder, what are we left with? Okay, so 2x negative 5. So I put this one in specifically because now we have a b, which is negative. And please watch out for your brackets. Please remember, because negative times negative is a positive. Okay, so I substitute that into my formula, and this is unfortunately a formula you're not going to get on your formula sheet, so remember this. Okay, so now again I'm going to substitute. We find that as 5 over 2 wherever I see x, and our remainder for this question would be 17. Okay, so please make corrections where is needed, And this is a fairly, how can I say, easy concept, the remainder theorem. So if I go back to my definition of it, so the remainder theorem states that if a polynomial fx is divided by a linear polynomial ax plus b, then the remainder r equals f negative b over a. So if I divide my long one by my short one, what am I left with? Okay, that's that. There's nothing difficult about it, and you just need to remember your formula for it. Okay, so as soon as you see remainder theorem, you're like, okay, negative b over a. Then you substitute that in. And for the remainder theorem, example 2, okay, when gx equals x to the power of 3 negative px squared plus x plus 1 is divided by x negative 3, the remainder is 4. Now, from the get-go, you're like, okay, that's weird. I already saw p here, so of course your mind is going to go to find the value of p. Okay, what is the value of that? Okay, now we have our remainder theorem that we just did now, asking like, why would they ask us that now? Okay, so the remainder theorem is 4. So we already know that r equals to 4. Okay, so it's the same as before. R equals f bracket negative b over a, and we substitute that in. So we have our a as what's in front of x? 1. And our b is negative 3. So then r equals g 3. So wherever I see x in this one, I'm going to substitute in 3. Okay, so here we did exactly the same as before, but of course we now have an unknown value here. But because this is unknown, we can't have it. But in the beginning, they told us the remainder is 4. So I'm going to substitute this with 4. Okay, r, they said, remainder is 4. So we have 4. Okay, then easy, we solve for p, which is negative 9p equals to negative 27, and p equals to 3. Okay, so when they ask you a question like this, the remainder is 4, you're still going to have to do your r equals f negative b over a to find what you need to substitute into x in order to find p. But because they told you the remainder is 4, you're going to substitute where your g3 is with whatever they told you the remainder. So usually our question would be find the remainder, but now it's given, and now we have to solve whatever they ask us. Okay, and that is the remainder theorem. There's nothing hectic about it. There's not much more to it. So the remainder theorem and the factor theorem works together, and we will do the factor theorem up next. But for this, please make notes. I want you to know when we go through more examples, when we do the factor theorem, when calculus builds on each other. So please, I need you to know this very well. I need you to remember the formula and how to implement it. So please make notes and make corrections where needed.